The scale of DoorDash is so large, and we have, like I said, tens of thousands of PRs a week. So the cost of using a third-party solution would be extremely high. And that's part of the reason why we were able to develop our own code review agent called Flux, because we found that we were able to reach the same performance and give it specific context for like the DoorDash code base.
We're here for the next episode of First Pass with Saketh, an AI researcher at DoorDash following their acquisition of Metis. We'll be talking about how DoorDash is building a custom AI solution for code review. Saketh, thanks for coming on.
Of course. Thank you guys for having me.
Well, every engineer I know is using code generation in some way, shape, or form, and that's creating problems throughout the rest of the software development lifecycle. Particularly, code review is becoming a big bottleneck as engineers have to spend time reviewing code that's generated by AI and make sure that it's production quality. What is the scale of this problem at DoorDash, and how do you go about solving it?
Yeah, so here at DoorDash, we've seen AI spend, particularly for coding, go up a lot in the last months. So we see thousands of PRs rolling in every single week. And the biggest bottleneck for that is obviously code review, because now that models are getting so fast and so good at coding, we're able to generate a lot of lines of code. But code review is the big bottleneck because we want to make sure we're not pushing AI slop to production.
I love talking about post-training. I feel like so much innovation is happening at the post-training phase. It's maybe like the least talked about, at least more publicly. Anything you can share with us about how you went about post-training the models to do this, whether it's different base models you used or how you set up reward functions? You know, we'd love to kind of hear some insights on how you did the post-training for this.
Yeah, so for code review specifically, actually, we focused on more of the harness engineering side of things rather than post-training. So we were able to see a lot of gains in making like a multi-agent architecture for code review. So the way we approached it was we made a scout model and a deep review model, where the scout model is essentially like a lighter weight model, like an open source model such as like Kimi K3, for example, that essentially goes over the PR and the base files, and it emits like some findings and some hints to then a deeper review model, which could be like a GPT 5.6 Soul or like a Fable 5, that will then take these hints and these findings and these files and then generate the final output, which is a list of bugs with like critical, high, medium, or low rating. And that's what is surfaced to the engineers here at DoorDash.
Super interesting. I mean, there's lots of talks on harnesses, and we had Mate from Databricks on the other week to talk about Omnigen and their meta harness that they're building.
Yeah, I'm a big fan of Omnigen.
Oh, nice.
Yeah.
What are some of the biggest challenges in building a harness that either you or your peers or just anyone building agents face?
Harness is a super vague term, obviously, because the way I think about a harness is it's everything around the model when you're making an agent. So that includes like the tools, the context you're providing the agent, and even the prompts. So when you're saying like building a good harness, it can mean like various things. It can mean like making sure you're giving it the right tool access, like how many tools that is, whether it's like for code review, it could be like 10 tools, but for some other agents, like consumer-facing agents, it could be up to like 30 to 50 tools even. And then managing like the memory and the context of the agent is also super important. So making sure you're not giving it too much to work with, that's going to confuse the model, but also not giving it too little context. So for the code review problem specifically, we want to make sure that it has all the accurate like diffs and all of the accurate context across files or even across repositories, that it can make the right conclusions when it comes to surfacing bugs.
Yeah, awesome. And what about DashBench? I think evals are another, hot topic, tons happening in that space. How did you go about constructing DashBench? How did you evaluate the success of the code reviewer? How did you think about false positives and false negatives? I think you talked about this in kind of the release blog post, but maybe walk us through DashBench.
The idea for DashBench came up because we were thinking about what model combination to use inside of our multi-agent architecture in production. And we were kind of taking wild guesses about which models to use, and we thought maybe A/B testing would work. But then I had the idea of maybe building like a benchmark, because code review is a generally like pretty verifiable problem, in that if we can get our internal engineers to annotate a set of PRs, in this case it was like 105 PRs, if we can get them to annotate the bugs in their own PRs, then we can have a ground truth data set that we can use for the benchmark. And then we can run a ton of model combinations. So we can run open source with closed source. We can run 2 different Claude models. We can run 2 different GPT models. And we can try out all these various combinations on past PRs. And then we can get an agentic judge, so like another LLM, to essentially grade how good these models did. And from there, we can find out, hey, this combination of models works the best, and we should use this in production. And then from there, A/B testing gets a little easier because we can use like the top 3 combinations and then try those out for weeks and then get feedback from our own engineers saying like, hey, I prefer this new code review agent. It's a lot better than the one we were using a month ago.
And Jesse from Decagon, who I think we're going to have on in a couple weeks, he had an interesting post talking about the evolution of their model usage from kind of heavy frontier now to heavy open source. As you think about this model soup that you have running, different models doing different things, how has your usage and progression of kind of like frontier versus open models evolved over time?
When it comes to code generation, I definitely personally prefer frontier still. I think the reasoning level of like the frontier models, whether it's 5.6 Sol or whether it's Fable, are still a step above the open source models. But yeah, we definitely see large gains when it comes to open source models, like specifically Kimi and GLM are some really good open source models, and even Inkling that released recently. So they're definitely catching up. And they're also optimized a little bit on the benchmarks. So when we use them in actual production, we have noticed that the frontier models are still the best for some of the harder tasks. So like in the code review example, the deep review model that we use, we still prefer the SOTA closed source models such as Fable or GPT 5.6 Sol, because we find those like are way better at recall and finding like the critical bugs that could potentially break something in production. And that's obviously the most important thing to catch.
Awesome. Well, like last one for me, and then I'll pass the mic back to Palak. But another big debate is just ROI. And like, what's the ROI of some of the spend? I think you also talked about this in your blog post. But walk us through how you thought about things like the cost per PR and the ROI of kind of like a code review tool and kind of like AI encoding more generally.
That's a great question. When it comes to cost for code review specifically, we find that code review is actually not nearly as expensive as code generation. So if you're spending, let's say, $30 to $50 generating like thousands of lines of code, and you're only spending $5 to $10 on the code review part, that part is honestly the most important part of the process. So it's okay to spend a couple extra dollars here and there. That's like my personal philosophy when it comes to code review. But we still obviously want to optimize for cost and not just waste tokens and waste cost. So we were able to formulate like a performance versus cost trade-off of the different model combinations when we made DashBench. And from there, we were able to see like, hey, we can achieve the same performance with this model combination without having like a degradation performance.
So what does this mean for engineering teams? How do you recommend they solve the code review problem? Should they use something off the shelf? Should they train their own? Or what combination of models should they be using for the code review process?
Yeah, I think it definitely depends on the scale of the company, obviously. I think some companies, it definitely makes sense to use third-party solutions. But for DoorDash specifically, the scale of DoorDash is so large, and we have, like I said, tens of thousands of PRs a week. So the cost of using a third-party solution would be extremely high. And that's part of the reason why we were able to develop our own code review agent called Flux, because we found that we were able to reach the same performance and give it specific context for like the DoorDash code base, whether it's like the back-end code base or the front-end code base, and give it this cross-repository context that was able to make it up to par with a more expensive third-party solution.
And how should teams think about future-proofing this? How should they think about making sure their code review process is continuously refined? As you mentioned, it's so important to make sure what you check into production is actually working.
The thing we do there is we just run various different new model combinations on DashBench. So that's the most useful part of DashBench, in my opinion. When a new model comes out, such as Inkling, which released recently, we can just run it with like almost like a click of a button. It's not that simple, but it feels like the click of a button to run it on the full 105 PR set. And immediately we get results we get traces into how the model does. And we can get an idea of, hey, should we put this into production for a week or two and maybe A/B test it with our current code review agent? Or is it maybe not up to par with our current production agent and we can just wait for the next new model to come out? And we've seen in the last month, whether it's like the Chinese open source models or the new Claude models or GPT models, there's been so many model releases. So I think having internal benchmarks is super crucial to keep up with that.
Awesome. Well, thanks for coming on. It's really awesome what you guys are working on.
Of course, thank you guys for having me.